My talk is just how to be a better developer and the steps you need to take to constantly improve yourself. My name is Jacob Mather. I'm co-founder of Point 5 Foundry. We're a small, like all-in-one shop. We do client services and we're building products and just sort of getting off the ground still, but things are coming along nicely. I've been programming for pretty much all my life. I've been doing it professionally for about the last 14 years on and off, and working with PHP for about the last 10. Just so you have an idea of where I'm coming from and just how I've gotten to this point. The biggest thing that we have to know as developers is we have to be ready to educate ourselves continuously, because the most important thing is to keep up on the information that's coming out, because every day there's a new product or a new service or a new technology that we have to learn, or else we're going to be falling behind and we're not going to be ready to take on the next challenge. So where to start with that? You have to know your stack enough to debug. Everybody has all these technologies that we use, and every once in a while you'll hit an error that you just don't know what that error means. But you have to have that knowledge of your stack to recognize where that error comes from. Knowing just how that error page forms gives you an idea of whether it's Apache going bad, or a database problem, or just a problem in your code. The one that comes to mind the most is, I can't even remember the name of it because the name is so weird, but when you use the double colon in the wrong spot.
The one that's
yes.
It's like one Nudo or something like that. The really long Nudo.
Yes, exactly. You'll see that and you'll go, what is that? And if you don't know what to look for. The next part is to pick an editor and use it. Your editor, your IDE, it doesn't matter if it's a text editor, if it's full-powered like PHP Storm or Eclipse or whatever. Pick one and use it constantly. It will teach you tips and tricks that you can use to program faster. It will have ways to more advancedly debug your code. It will help you refactor things when things start going wrong. It provides a set of tools and will help you get more done more quickly. And it's just a part of improving as a programmer. Push outside of your comfort zone. This is really important because that means you're learning. If you're just doing what you know how to do and you're not really improving, you're falling behind. And pushing outside of your comfort zone improves your ability to do that more. Find a nerd crush. I didn't understand the importance of this for quite a while, and then I found a nerd crush. And what's really funny is my nerd crush doesn't even really program majorly anymore. His name's Patrick McKenzie. You should probably look him up if you do any sort of business stuff, because he talks all about A/B testing and just how to approach the business of programming as a much better way to sell yourself in a way to make more money. And I have another talk that I'm working on for that. So it's just really interesting stuff. But find a nerd crush. Find somebody that you can want to be more like. Learn common patterns. Learn design patterns. Learn the ideas behind what we do as programmers. There's my brain is, there's too many people looking at me. It's just not working. There's the observer pattern, and there's strategy pattern, and there's all sorts of things for problems we've already solved that if you don't know about, you can't use. Or if you don't know about them, you won't use them correctly. And we've solved all of these sorts of things, and so there's no point in wandering aimlessly through the dark. They're documented. Go out there, look for them, and learn. The biggest thing for learning a new technology is to pick a pet project. Having a pet project means it's something passionate that you care about, something that you'll work to learn those new things to build. Otherwise, you're not so motivated. When you're at work, you're just doing your thing, you're just getting the job done. And so having a pet project gives you a reason to push outside of your comfort zone. It takes 10,000 hours to become truly objectively good at something. That takes a lot of time. That takes a lot of dedication and a lot of commitment. You must learn to learn. The biggest part of what we do is learning all the time. I mean, it's new technology, it's new tools, it's new problems. If you can't learn to learn, then you won't be able to pick up things fast enough. And it's all practice. I hit the button twice. And you know, a lot of people won't do something because they're afraid that they will fail. They're afraid that it won't work. They're afraid that they won't be able to pick up the skills necessary to do what it is that they want to do. But if you can pick up new things quickly, the only thing you will ever fail at is not trying. The easiest way to know that you're on track is to look at your code from a couple months ago, or even further, and just see how far you've come from the stuff that you programmed 6 months ago. See how bad that code looks now. If that code it doesn't look too bad, then you should probably try and work on learning a little bit more, because it's just even after doing this for 10 years, I can look at stuff I programmed 6 years ago and I can't believe that even works, much less that I programmed it like that. Sometimes having a cheerleader helps. A lot of the times I notice that if I don't have outside input into what I'm doing, I just kind of get, I don't care. I care as much as like somebody else will care about what I'm doing. And so for those people, having a mentor can really help. It gives you somebody that you can talk to about problems you're having, somebody who's knowledgeable about the stuff that you're working on, and it gives you a way to just have somebody else push back against the ideas you have, to just sort of self-check. There's a group of people out there running a community called PHP Mentoring. I'm actually a member of that community as well. We're on IRC all the time. It's really fun. If nothing else, stop by, say hi. So, all this talk about learning and, how important it is fine and dandy, but how do you know what to learn? Be a part of the community. It doesn't matter if it's on IRC or forums or mailing lists or user groups like here. If you're not a part of the community, you don't have that outside input as to what's like new and interesting and what's upcoming and what's on people's radar. The other part is you have to take advantage of the community. You have to stop reinventing the wheel. People have already solved these problems before. Don't solve them again. There's password hashing libraries. There's libraries for automatically manipulating images and doing crops and resizes and shifts and all that stuff. This code is already written. There's no reason to write it again. Stop being afraid of other people's code. I had a problem with this one at first. It's just, because how do I know their code is any good? I know I'm a decent programmer, and I know a lot of the programmers I met aren't. If you don't trust the person's code that you're using, find someone else's. That's the other thing about the community. More than likely, there's 3 or 4 projects that are doing what you're looking at. And so, just look around. If you're not happy with the code quality or the product that you're getting out of that free project, then look around. I'm sure there's probably another solution. The other thing is stop solving uninteresting problems. Once you have stopped reinventing the wheel and aren't afraid of using other people's code, you can do things like use a login library that's already written. Because how many of us have written a login page? How many of us want to do it again?
Oh, I love it. Only from the standpoint of I wrote it 6 months ago and it embarrasses me.
Okay, fair enough, fair enough. There's a certain value in improving and in doing something again to measure that improvement. And there's definitely that quality to it. But as far as the value you get from rewriting it when somebody already has one written that's 10 times better, and probably code vetted and tested and all that stuff, use someone else's code when you can. It lets you focus on the things that really matter. The other example I have as far as stop solving uninteresting problems, has anybody worked with OAuth? It's no fun, is it? And there's some.
It's fun only because it's a challenge. And
Yes.
If you conquer it, it's rewarding, but you'll swear a lot on the way there.
Right.
It's
Yes.
hard to break them.
And there's libraries already out there that solve these problems. And it'll save a ton of time and a ton of frustration. And, you know, the biggest problem is with using other people's code is you have to deal with dependencies. And dependencies can be hard, but they're not that hard, at least not anymore. There's one software package called Pair, a software package and a library and all sorts of stuff for dealing with, you know, generally system-level code installs. And then there's a new one called Composer. That's actually from the Symfony community, and it's really nice. So we're going to do a little Composer crash course. Here's a sample configuration file for a library called Monologue. It's just a tool for abstracting all of the logging that you do. It makes it really simple. You see, it's JSON, and so it's a known standard. We just say there's a require section and tell it the package we want and the version we want, or at least the general version. There's lots of specific details. I'm just trying to give you kind of an overview. I'm trying to expose people so that things aren't scary anymore. So the first thing we do is install Composer. So we have the directory, and that has our composer.json. We go to the website, we copy and paste the command to use, and then Composer's installed. Now you have to run Composer. You go back to the website, you copy and paste the command to use, and everything's installed. You have the lock file, details all of the software that you currently have installed, so that the next time you run the install command, it will install the exact same versions, so that you don't have to worry that when your teammate goes and runs install and tests stuff, that it breaks, because since the last time you did it, somebody updated a software package. They will get the exact same version, so you don't have those strange dependency gotchas that you have doing it other ways. Now, how to use Monologue? It's really simple. All you do is you take that autoload.php, there's an autoload.php that's created automatically in the vendor directory. You load it up, and it loads an autoloader that will access everything that you asked for. You don't have to do any sort of includes, any requires. It's just all there. So all this learning is great, but it takes time. And so the next thing I want to show you how to do is how to make time to learn how to do this. First, the key thing is you have to automate everything. Anything you have to do by hand, you'll mess up eventually. It's given, you know, it's just you do it enough, you'll find something, you'll miss it. So the first thing is automate your history. Use version tracking to keep track of all the changes that you've made throughout time and, you know, understand the changes you've made to your code and how they got there and how bugs were introduced. And this will help you self-analyze how you can make code better. It'll also easily allow you to work with teams because it provides a standard that everybody can work on. Use Git, use Mercurial, use Subversion, I don't care. Pick one, use it constantly. Seriously. Using it is an entirely different thing. There's whole presentations, there's sets of presentations, all on using little pieces of it. That's way outside of the scope, but start looking into it if you're not already. Automate your testing. Now this is a great quote. I've been talking back and forth with Chris Arches for quite a while. Computers are great at doing the same thing the same way every time as much as you ask it to. Humans, not so much. The fact is, all code is tested. Every line you ever write will be tested. Too often, it happens in production in front of actual users. There's a better way. Decide to test your code up front. Control how and when you test to get the most benefit out of it. Do everything you can to ensure that show-stopping bugs don't get in front of your users, because that hurts your ability to gain confidence with them. This is all a game of getting trust of your users. And the more they see your site error, the less they'll trust you. How long did it take everybody to start using Twitter constantly again when they were having massive load issues, and every time you went there you saw the fail whale? You know, it's a matter of trust. What happens if you don't test? You link to pages that don't exist. You link to pages that just don't work. So, testing is really easy. I want to show you a real quick example of how to start a basic test, just so you have an idea and it's not scary anymore. First, obligatory contrived example, because every test needs something to test. And so we have our thing library, and that takes another system because we're going to show you a little bit of a trick. This thing relies on something else in order to calculate two things. And it sends those two things to the library that we bring in and multiplies it by 100 and returns the value. So we start our test class and we add our first test function. It starts with tests so that PHP unit knows that it's a test to run. You can also use annotations and other stuff, but this is just the easiest. We're just getting started, trying to make it not scary. So now we added a whole bunch more code. We create our test library, we pass that, we create our library, we pass that into our thing, and we run our assertion that the library is working as it's supposed to. The problem with this is we're no longer doing a correct unit test. We're creating an actual object of my library that now this test depends both that thing does what it's supposed to do and that my library does what it's supposed to do. So that when we pass it into thing and we test that, it's testing both things at once. And unit tests are supposed to only test one thing so that you can identify what has failed. Here's the right way to do this. You create a mock. It is a fake object, basically, that wraps around your original class. And then you can tell it how it's supposed to behave. You say that you're expecting this function to be run once, and the function's name is do something, and it will return the value 10. And then you pass your faked class into your thing, and you run your assertion. Now, if you look, we even send bad data in. And that's just to point out that the actual function on my library is no longer being called. That it's just returning 10, and because 10 times 10 times 10 is 100, the test will pass. If we look back again, we make sure that we see that do something is past the variable, so that's why it's not breaking, and that's why it's still a good test. Now, sometimes when you use getMock, you'll get errors. It'll say something about the constructor, it'll say something about a requirement. So I want to show you real quick that there's something called mock builder, which is kind of like a step-by-step version of getMock, where you can introduce other options like disable the original constructor, just in case our constructor depends on us passing through something else. And so we can just keep that from happening. The other thing that happens when you start to test your code is you understand a little thing that I don't really think enough people talk about, is you start to understand that you know your software is good instead of just thinking your software is good. And it's a subtle distinction, but it really kind of changes how you approach what you do, because when you push code up into production, you go, I know this works. I know this works to a certainty of every possibility that I can think of that I've written a test for. I know everything will work. So what else can we automate? We can automate deployment. This is a quote that I found when I was looking for things, and I really liked it. Prayer should not be a part of the steps in the deployment process. It's just, there's specific tools already built to help you handle deployment. There's Capistrano, there's Magallanes, there's Fing, there's, you can build your own bash scripts. It really doesn't matter. Deploying something is a process. And so the more you automate that process, the less you introduce human error. The other thing is, what I like to do is I'll hit my deploy script and let that start running. And then I go back to IRC and I talk. Deployment is the new compile. The other thing you can do is automate your platform. There's a lot involved when you're dealing with trying to manage servers and trying to manage how you're deploying things and how you're running things. There's a lot of details. And there's services out there that have already abstracted this sort of information into basically a configuration file. And they can automatically set up your server and install MySQL and give it a password and install like Redis, and they can do all that stuff automatically, and you don't have to deal with any of it. It's not for everybody, and there's certain constraints, but it's something to look into if that's a concern that you have, especially if you don't have operations people, if you don't have somebody who knows servers really well. It's something that you should look at just to remove that sort of liability. The other thing you can do is automate your process. Using continuous integration, you can take those automated tests that you've already built, and when you submit your code to your source code repository, a hook will trigger your continuous integration, which checks all the tests. And it goes, okay, I've checked all the tests are fine, so I'm going to automatically deploy this out to production. And all you have to do is just commit your changes. So I've talked a lot about a lot of stuff right now, and so we're going to step back a little bit and talk a little bit more higher level stuff, just to sort of take a break from the technical details and that sort of thing. Our actual job as software developers is to solve problems. A lot of us approach it from writing code and doing things, but our actual job is to just think and solve a problem in a way that works for everybody. So when you're solving a problem, there's a couple of things to keep in mind. Solve a problem that your client actually has. A lot of us tend to not do that so much at first. We get lost in the details of, oh, I could do this, and I could do this, and I could do this. And no. Just take a break, look at it, solve the problem that your client actually has, and do it with a solution that makes sense. They have to actually understand what you've built for them if it's going to be any good. And the last thing is to make sure that it actually works for the reason that you built it. If you build something and the client understands it, but it doesn't actually do the job they need it to do, it's not any good. So let's say, for example, you're running a conference, you built your own ticket sales system, you need a list of people who are coming, and you have to check them off. Because when you go to conferences, they give out badges, and it's just part of the organizational structure. This is a true story. So it's easy, right? You do your SQL statement, you select all the tickets, and then you join the users onto those tickets, and you get this nice list. Find Mr. Potentia. He's there. Find Mr. Evans. He's down at the bottom. It's easy. There's 4 of them. So now we're going to find Mr. Jones. Less easy, is it? There he is. This worked with 4 people. This didn't work with 40, and this will not work with 400. So let's really solve the problem. Let's look at it. And the problem was, if you look, they're all in chronological order. They're all in the order that they bought the tickets. Nobody's going to come check in that way. So we add the order by to add the last name and the first name, just so that everything makes sense when you're trying to look it up. Once you've decided on the solution, you'll have to decide how to solve your user's problem. And it's time to make the magic happen. So we get to talk about code a little bit more. Code is kind of a frenemy, really, when you think about it. Because the more code you write, the more code you have to maintain. And so even while you think that your job is writing code, your job is kind of writing the least amount of code possible to solve the problem. Because code rot is real. You'll come back to things in 6 months and a year, and you'll go, how did that work? And the less code you have, the less problem you'll have with that. Every line of code you write is another place for a bug to be introduced. And there will be bugs. So when you write code, remember that you'll have to maintain it. And remember that you'll have to come back and deal with it. And more than likely it will be you. Or if it's not you, it's going to be someone who doesn't have the mindset that you have. And so it's even more important to make your meaning of the code clear. If you have to take 3 lines to do something, just so you're not shoving 35 variables in a single line, do it. In the end of the day, it doesn't matter. It's much more important that the code is readable. Spaghetti code. I actually came up with this when I was talking with a friend of mine. The only way to test spaghetti code is the same way you test spaghetti. You throw it against the wall and see what sticks. Spaghetti code actively resists testing because everything's just mixed in. So when you write code, write your code deliberately. Use proven methods, and you can make your job easier. It'll let you build software faster, and it'll let you build software with higher quality. Methods for doing that: don't repeat yourself. If you're using the same bit of code over and over and over, abstract it into a function, into a library, into a class. Whatever you want to do, just centralize it in one spot and then pull it in. That way, when the requirements change, because they always do, you only have to go one place and you'll fix all of them. Another thing I want to talk about is solid development. It's a methodology for producing higher quality code. And it's kind of an acronym. Single responsibility means that each class you build, have it really only do one thing. That way there's only one reason you have to come back to that class to change it. Open for extension means not purposefully making things, private variables or private functions, except for whenever it's only local to that particular instance. Like their subclasses is really more rule for the classes that you use to extend your base classes. They shouldn't change the rules. If you have something like our thing class, which is expecting MyLibrary, any class that you extend from MyLibrary should take those same variables and do the same sort of thing with them. It shouldn't add more. It shouldn't make them optional. It should always adhere to the contract given. Incorporate interfaces where you can, because that will let you build your code in individual silos, basically. You can build your entire functionality in one little code base, and then you pull that in and you just implement your interfaces into your objects in your main project, and you're ready to go. I actually did this with an SMS system that I don't know if anybody's ever worked with building an SMS system, especially with a shortcode. It takes about 3 months to get that shortcode live. It takes forever. And so I had to build all of this software without any way to actually do a live test. And so unit testing and interfaces became integral, because then I could test the entire system end to end. And then when I was ready to make it live, I just had to implement a couple interfaces and make sure that the adapter worked the way that I wanted it to, and I had it running live in 30 minutes. And just the feeling of being able to do that and knowing that code all worked was just incredible. And the other part is depend on abstractions. Like we showed with pushing the MyLibrary into Thing, use dependency injection to help with the single responsibility rule of, if it's outside of what that one thing that library should be doing, put it in another library and bring it in. It's not a big deal. It's easy to do. And if you're worried really about performance issues, there's tons of other things you can do before you start worrying about that. Proudly invented elsewhere is all about using less code you write yourself. This is actually a phrase from Larry Garfield. It's hilarious because I was talking about the same sort of thing and he came up with this nice little acronym, and I like it. It's using other people's code, because the less code you write yourself, the less code you have to maintain. Using other people's software lets your code improve, lets your project improve while you're asleep, because they'll still be working on stuff and you're not. So we're near the end of everything I want to talk about today, but there's still one more thing that's really, really important to advancing your career and your abilities as a developer. You are only as good as the team you support. Everybody's different and everybody's better and worse at different things. And having a team lets you put those better and worse things together and just come out with things that you could not do individually. Like me, I can't design. These slides were not designed by me. These came from my designers, oddly enough. They just, you don't want me picking colors. I'm colorblind. It's a bad deal. But letting other people help you, and you can help other people. The biggest thing for one of my designers is we were building an image gallery, and she was literally going to have to spend hours resizing images and putting images in pages and making all the image gallery things work. And I said, look, give me the files. I'll spend 2 hours writing a little bit of code, and you never have to do this again. And how happy that made her, I can't even describe. She still tells me thanks every once in a while. And it's nice. It's just, you have to realize where you can help people and actually spend the effort to take the time to do it. You are not the only geek. You are just the only geek that cares about the code. As crazy as you get about that line of code or that structure of that object, they get about marketing, they get about the colors on the website, they get about the making sure everything comes in on time. So let other people play to their specialties. some typical job roles that you'll encounter, being a developer, designers. They make things look pretty, but they do a lot more than that. There's things like information architecture. There's the psychology of what colors different things will help people emote. There's all sorts of things that they do that I can't even begin to understand. I know little bits of it from lots of research, but I know enough to know that I need to respect my designers and trust their decisions on things and help them where I can. There's project managers, and they really do not get enough appreciation because while your performance really only relies on the code that you're able to write, your project manager relies on you and your coworkers and everybody else that they're supposed to be managing. And if even one of those people don't deliver, it's on the project manager. Their job is to make sure that the project comes in on time and on budget. And so if your project manager is like hounding you, it's probably because their butt's on the line. And so give them a little bit more slack and try and work with them. And if you're having problems with them, go to them and talk to them and ask them how you can help them. Ask them what you can do. Because you're a programmer, you can automate things, and so it's much more easy for you to find something you can automate to make some time to help them than it is for them to just magically make you do more work. Marketing and sales gets a lot of bad rap for coming at you with crazy ideas of things to build. Usually, if they have this like harebrained scheme that they want you to start programming for, they have somebody willing to pay for it. And somebody willing to pay for things is how you get your paycheck. And so, give them a little bit of slack and let them be a little bit crazy and let them give you some stupid requirements that you don't understand because they're talking to the customers and you're talking to the code. And so if they're coming at you with requirements, they probably have somebody willing to pay for this, probably more than one person. And so give it a chance. Just give it a try. Let it run. See what happens. There's a couple other groups internally for us developers. We have sort of segments. The front-end developers get a lot of crap, really, because they have to deal with JavaScript. I mean, back-end developers are picking it up more with Node.js and everything, but for the longest time, front-end developers have had to deal with JavaScript. And JavaScript is interesting. It can fight against you without you even knowing it, because there's all sorts of rules that come into play with JavaScript that you would never even dream of in PHP. There's threading, there's concurrency, there's scope issues. You can set up something that looks completely logical, and when it runs, it actually means something else entirely. Like you'll go to use a variable and just stuff won't be working right, and it's not clear. It makes no sense what is going on. And you just kind of have to know. And that goes back to knowing your stack. You have to know when you start to see errors this weird that you haven't encapsulated something correctly in scope. The other thing that they do is they make users love your code. As a back-end developer, you want the front-end developers happy with you because they're going to make the software that the people actually interact with that makes your job relevant. And there's also back-end developers. The back-end developers are the typical programmers. They're the people who don't interface with people well. They're the people you lock in the room with pop and pizza and just expect to code. They're the quintessential programmer. And if you have somebody that meets this stereotype, be a little bit more low-key with them. Don't, run back saying, oh my God, we need this thing by like Tuesday, because they don't really deal with that stuff. They deal with longer-term stuff. They deal with long-term planning. And nobody actually sees the value of the stuff they build except for you. As a front-end developer, you're the only person who actually sees the value in what the back-end developers build, because you're the only one who uses it. And so just be a little bit more low-key, give them a little bit of room, but don't, let them slack. Make sure that they're, still doing what they're doing. A couple unfortunate truths with all of this. Not everybody will be qualified to do the job that they've been hired to do. Not everyone who is qualified will actually be any good at what they're hired to do. And not everybody who is actually any good at something will ever be given the chance to do it. The last thing I want to say is, how to not be that programmer. We know the in the room, locked in the room, nobody else interacting with you, Coke and Jolt and whatever. Take some time, actually learn how to make friends, actually learn how to make small talk, and your career will go much smoother. You won't have to be, that guy in that room that nobody talks to because you're socially awkward. You can just learn. It's a skill we have. We can learn things. And so spend a little bit of time and just get acquainted with it. Now, do you have a great team? If you don't know, then you probably don't. Because it's something that you realize once you have one. And there's only so much you can do to try and fix that internally. If somebody's like majorly slacking off, you can report them. And if nothing's still happening, it's time for you to go. Because you can't control anybody else. You're only in control of yourself. And there's no sense in just getting lost in those office politics and getting, just fighting with it. There's no point. So if you're having a problem with the team that you're on and the efforts that you've taken to address it haven't been, received, start looking. Especially in our market, we can find work anywhere. Having a great team really, really matters. It's everybody together pitching in with everybody's ideas that mean that you can build stuff that wouldn't be possible without it. So take away from this that learning is the core of what we do. And community is how you know what to learn and how you know where you should grow your career. And automation makes time for you to do all of this. Solve problems, don't write code, because problems are what actually make money. And back up your team and let them back you up as well. I want to thank everybody, and this is my first talk ever, and I appreciate your time, and I really want feedback.